Let's solve now problem 46 from Siegel's biochemical calculations, and we start with problem 46a. So again, this is the Siegel number 46a in page 93. And this problem asks to calculate the volume of a 0.1 molar solution of KOH required to titrate completely 450 milliliters of a solution 0.25 molar alanine hydrochloride. Okay, so that's what this problem is asking. Let's approach that problem. First, we need to remember what's the form of alanine hydrochloride. So there are two ways of writing that. One is the conventional way, that's NH2 CH-COOH, the methyl group in here, and hydrochloride. However, like we discussed before, this is not very informative for us. We rather prefer to write in the form that's protonated here. In this case, it's fully protonated alanine, and we know then that in order for us to titrate completely, we have to have enough hydroxide to remove this proton, and we also have to have enough hydroxide to remove one of the protons from the NH3 plus group. So in other words, for each mole of alanine hydrochloride, we are going to need 2 moles of KOH. So the equivalence in here is that we need 2 moles of KOH for each mole of alanine hydrochloride. So let's calculate how many moles of alanine hydrochloride we have here. So the numbers of mole of alanine hydrochloride it's going to be, what was the concentration, 0.25 molar, right? 0.25 molar times the volume that we are using. The volume has to be in liter here to calculate the number of moles. We have 0.25 times 0.45, so that equals 1125 mole. So this is the number of moles of alanine that we have, but we know that KOH, the number of moles of KOH, is going to be twice as much, because we already analyzed that relationship here, that 1 mole of alanine hydrochloride requires 2 mole of KOH. So that 2 times 0.1125, which give us 0.225 moles of potassium hydroxide. The problem is asking the volume that needs to titrate that. We know that the solution of potassium hydroxide is 0.1 molar, so then we can calculate the number of the volume, because we have the relationship that the molarity is the number of moles divided by the volume in liters. Therefore, the volume in liter equals number of moles divided by the molarity. So the number of moles is 0.225, and the molarity is 0.1. So in that case, here gives 225 liters. That's the solution for the problem.